in general works. So training data set, then a learning algorithm, it depends on you what you are going to use and the input variables or features, then go for hypothesis and prediction, then actual hypothesis, then best fit line. You need to look for it. So there are 6 steps which I have discussed earlier. So you need to remember those 6 steps. First step, initialization, calculation of the predicted values, then cost function, then go for gradient, update the values by iterating the things, and then go for repetition steps, that is for updating the purpose. Now, the choice of learning rate is crucial in gradient descent, as a learning rate that is too large can cause the algorithm to overshoot the minimum, and learning rate that is too small can cause the algorithm to coverage slowly. So there are different variations of gradient descents, including batch gradient descent, stochastic, and mini batch gradient descent, which I have discussed earlier. So the choice of gradient descent algorithm depends on the specific problem and the requirements of the model. Now, model performance needs to be evaluated, for which there are several things which the people use to apply for model performance: inquiry or investigation, that is MSE, mean squared error, then root mean square error, RMSE, mean absolute error, MAE, then R squared, then adjusted R squared, then F statistics. So what are the details we need to learn here? For example, SSR, or sum of squares regression, which is calculated by taking the sum of the square differences between predicted values and the mean of the dependent variable. It represents the variability in the dependent variable that is explained by the independent variables. Mathematically, it can be written as it is there. So a statistical technique used to in regression analysis to determine the dispersion of data points, that is sum of squares regression, that is SSR. Now it comes to SSE, sum of squared errors. The squares error, that is calculated by taking the sum of the square differences between the predicted values and the actual values of the dependent variable, which you can see in this equation. So these are quite simple equations which you need to code while you are developing the machine learning algorithm. So here you can see the figure, how it could be understood in terms of graphical presentation. Then it comes MSE. This is also quite common. This metric measures the average squared difference between the predicted and actual values. It is calculated as the sum of squared residuals divided by the number of data points. A lower MSE indicates better performance, and the mathematical equation is written here. So you need to look for the observed values, predicted values, regression line, and then a scale difference between the observed and predicted values. Then it comes to RMSE, which is very commonly used and it is easy to understand. This metric measures the square root of MSE and is useful for interpretation of the errors in the same units as the dependent variable. Now you can look for mean absolute error, which is like much simpler equation, and it measures the average absolute difference between the predicted and actual values. It is less sensitive to outliers than MSE, but still provides a measure of the model's accuracy or performance. So next part you need to see is sum of squares. The total, that is SST, is calculated by taking the sum of the square differences between the actual values of the dependent variable and its mean. So here you can go for it. Now it is R squared. So this metric measures the proportion of variance in the dependent variable that is explained by independent variables, and it ranges from 0 to 1. So here you can see R square, SSR, and SST. These three are related to each other. So everything should be, these three terms should be clear just with one presentation. And here you can see these three graphs showing the R squared values and the line fitting things. Now, it can also be seen as the values ranges from 0 to 1 with a higher value indicating better performance. So that means here 0.95 performs much better with respect to 0.85 second figure with respect to R square, the lowest. So this is least performing system. This is the best performing system. Now you can go for multiple linear regression where by using some different software that is sklearn. But what I want to show here, so simple linear regression line, multiple linear regression line is just the mathematical equations, how they are different or close to each other. Simple linear regression could be represented by this simplest mathematical equation. Then it comes multiple linear regression, which is here, where you cannot see any square root or a square or something else. It's just a simple the sum of something. But here, when you are going to for polynomial linear regression, then you can see here the square of x and x raised by n. So here this equation is slightly different than this equation. So multiple linear regression line is very close to simple linear regression line, but polynomial has something raised by certain values. So next part is different regressions lines. What you need to see is how these simple or polynomial regression lines could look like. So this is simple linear regression line. If it is multiple linear regression, then it will be like this. But when we are talking about polynomial, then it is going something in extreme up or extreme down, some the line. Then next part is where I was discussing about polynomial, which you have already seen it now. So linear equation, quadratic equation, then cubic equation. What are the degrees and all the things which you need to understand. Now, assumptions of the linear regression, the fundamental assumptions of linear regression, what you can see here is the something like how to use it, what are the most important formula which you need to implement at which stage, and most suitable formula, most suitable like the terms which you need to. This depends on the goal of your project and the nature of data. So this is what you need to understand, and that is why I have introduced all these points which are mostly used for data scientists or data analysis purpose. So now, when we are saying little or no multilinearity between features, and one is saying little or no auto correlation in residuals. So it is all depending on the data plotting and then the goal of the data. So multilinearity exists, collinearity exists when the independent variables are found to be moderately or highly correlated. In a model with correlated variables, it becomes a tough task to figure out the true relationship of the predictors with the target variable. In other words, it becomes difficult to find out which variable is actually contributing to predict the response variable. Now, in the little or no autocorrelation in residuals, the presence of correlation in error terms drastically reduces the model's accuracy. This usually occurs in the time series models where the next instant is dependent on the previous instant. If the error terms are correlated, the estimated standard errors tend to underestimate the true standard error. Now, no heteroscedasticity, the presence of non-constant variance in the error terms results in Heteroscedastically, generally non-constant variance arises in the presence of outliers. So these values get too much weight, thereby disproportionately influences the model's performance. The normal distribution of error terms, for example, when you are going to plot normal distribution, some kind of analysis part, then is it really showing the normal distribution or no? Then you need to look for if the error terms are not normally distributed, confidence intervals may become too wide or narrow. Once the confidence interval becomes unstable, it leads to the difficulty in estimating coefficients based on the least squares. The presence of normal distribution suggests that there are a few unusual points that must be studied closely to make a better model. So this is what makes sense. The presence of non-normal distribution suggests that there are few unusual points, data points, which must be studied closely or deeply to make a better model. So this is what you need to understand from these plots. So thank you very